Hello and welcome to the Sleepy Narrator, where the questions stretch far, the answers move gently, and science takes its time, like a calm tide easing onto the shore. Tonight, we drift toward somewhere dim, not frightening, but hushed and ancient. A realm that begins just beneath the waves and extends into the most hidden places on Earth, regions more mysterious than the moon's surface. Tonight, we're sinking our thoughts into the deep ocean, or more precisely, into the puzzle of why so much of it remains untouched despite all our progress. It's curious, isn't it? We send telescopes to the edges of the cosmos. We place rovers on far-off planets. We map galaxies. Yet when it comes to the ocean, just past our toes, most of it is still a secret, immense, uncharted, and almost dreamlike in how distant it feels. So I wonder, where are you listening from tonight? And how far is the nearest coast to you, a few miles or 1,000? Amusing, isn't it? The sea is everywhere, and yet the deep is nowhere we go. If this gentle drift into wonder helps you unwind, if it soothes your thoughts, or gives your mind something soft to hold, I'd be grateful if you liked this video or subscribe to this quiet corner of science. It helps others find their way here too, to rest, to learn, or simply to float for a while. Now, I hope this journey won't stir your curiosity so much that it keeps you awake. But if it does, well, you'll have the company of anglerfish, ancient currents, and submersibles that hum like lullabies beneath the waves. So get comfortable. Let your shoulders loosen. Breathe slowly and deeply. And let's begin. Because somewhere between the sunlit shallows and the trenches that can swallow mountains lies the quiet story of why, even now, the deep sea remains mostly unknown. Have you ever stood at the shore and felt small? Not in a fearful way, not like being crushed by weight, but in that expansive, enchanted way. A kind of smallness that reminds you you're part of something far greater. The horizon blurs. The water shifts in silent conversation with the moon, and beneath those calm ripples an entire unseen world is breathing. The deep ocean stirs a very particular kind of wonder, not exactly fear, not exactly awe, something older, primal. It's the kind of stillness that makes your mind lean forward and ask, what else is down there? We speak about space as the final frontier, but the deep doesn't feel like the future, it feels forgotten. It isn't beyond our reach because it's distant. It's beyond our reach because it's right here, and yet still unknown. That closeness, mixed with alienness, gives it a dreamlike pull, like remembering a place you've never visited. And when we imagine the deep, we don't think in charts or data. We think in feelings. An endless darkness broken by flickers of bioluminescence, glimmers like stars trapped under miles of water. The lonely voice of a whale echoing through a dusky liquid expanse. A sense of pressure, stillness, secrets preserved. For many, the deep exists not in facts but in tailies, creatures with glowing fangs, ghostly ships drifting without crew, lost cities under coral domes. Even now, when we hear the phrase unexplored ocean, our minds often leap not to sonar or robotics but to myths, leviathans, abysses, forgotten wonders. Isn't it strange that part of our own planet feels so removed from daily life? We wake and read news from across the globe. We track hurricanes from satellites. We watch videos from Mars in high resolution. And yet, if asked what lies at the bottom of the deepest trench, most might say, I don't know, something strange. That strangeness is not only about distance, it's about perception. We tend to measure a place by how accessible it is, by how easily we can picture it or imagine ourselves there. A bustling city, you can smell the pavement. A mountain trail, you can feel the crunch of boots. Even space, for all its emptiness, is described in starlight, sleek ships, and radio signals. But the true deep sea is harder to imagine. Try to see it, not coral gardens or kelp forests, but the Hadal Zone, that pitch-black, freezing, high-pressure expanse beyond 6,000 meters. There is no sunlight, no natural sound, only the crushing weight of water equal to towers pressing from all sides. Our senses fail us there. No solid ground to stand on in thought, no cues to hold. And so our minds fill the void with invention. In psychology, There's the idea of the uncanny valley, the odd discomfort when something is almost familiar, but not quite. The deep seems to inhabit its own uncanny valley, known in theory, but unsettling in reality. It's still Earth, but sideways. And then there's the quiet. We often call silence peaceful, but the deep silence is different. It's not the soft hush of a bedroom at night, but the reverent silence of a cathedral carved in salt and pressure. It's a stillness so complete, it curves inward, as if the ocean itself is holding its breath. That kind of hush builds a psychological distance, not from fear, but from respect. The distance is also physical. We are air breathers who navigate by light and live in open spaces we can see and touch. The deep defies all that. It isn't merely hostile to human life, it's incompatible. If you descended to the average depth of the ocean without protection, you'd be crushed before reaching the bottom. Light vanishes within the first few hundred meters. Sound behaves differently. Gravity still pulls, but up and down become abstract ideas rather than fixed directions. That incompatibility makes us avoid it. Our minds favor what can be grasped. The deep slips away, not just from view, but from understanding. It's hard to dread something you can't define, and harder to claim something you can't inhabit. Maybe that's why we talk about the ocean in halves, the one we know, surface waters, boats, sunsets, and the one we don't. The shallow is ours. The deep another realm entirely. Still, we dream about it. We dream of life that glows, life that drifts, waiting in the slow beat of geological time. We imagine wrecks carrying lost cargo, vents breathing minerals like smoke, scars in the crust, sunken plains telling tales untouched for millions of years. For all its darkness, the deep is not empty. It's alive just beyond sight. And perhaps that is the most tempting part, the idea that, in a world seemingly measured and mapped, there are still places beyond our reach. The deep keeps its secrets not out of malice, but out of quiet patience, as if saying, "When you're ready, I'll be here." We often imagine exploration as conquest, planting flags, crossing thresholds. But the deep doesn't answer to ambition. It doesn't resist or welcome. It simply is vast, cold, patient, waiting for us to slow enough to hear. And there's comfort in that. In a world that accelerates daily, the deep is timeless. Not by magic, but by age. It has existed longer than language or maps or myths, and it will remain long after we are gone. So, when you think about why we haven't explored it, maybe the ocean isn't holding back, maybe we are. Not from neglect, but because the mind, like the body, has its own depths. And some can only be reached slowly, respectfully, with open eyes and quiet hearts. So next time you're by the sea, at the shore, or hearing the sound of waves, pause. Not for what you see, but for what you can't name, for what you almost sense. That pull beneath the surface, that mystery without a clear edge, that's the deep. Not just water, not just weight, but the part of our world that whispers discovery isn't always loud. Sometimes it hums softly, and perhaps that's why it remains unknown. Long before sonar scans and titanium submersibles, before the phrase deep sea ever entered a lecture hall, humans looked out over the ocean and imagined. We didn't just wonder what was out there, we built stories about it. The sea, especially the unseen part beneath its surface, wasn't considered empty. It was full, sometimes benevolent, often dangerous, always sacred. In nearly every ancient culture, the deeper you went, the stranger and more powerful things became. In the myths of Mesopotamia, the ocean was Tiamat, a vast, primordial goddess of saltwater and chaos. She wasn't simply the sea. She was the raw matter of creation. After a divine battle, her body was said to have been split apart to form the sky and the land. The deep wasn't just where life began, it was life itself, before it knew what shape to take. The Greeks told of their own abyss. The deep ocean belonged first to Okeanos, an ancient river said to encircle the world, and later to Poseidon, unpredictable, violent, commanding. Sailors spoke of storms and creatures that could pull ships into the dark. There were sirens, yes, but also whirlpools that seemed alive, krakens that rose from nowhere, and gods whose tempers could sink entire cities. In Norse legend, there was Jörmungandr, the world's serpent, so massive it wrapped around the earth and bit its own tail. It lived beneath the sea, coiled in shadow, and its stirring would bring about the end of the world. In Polynesian traditions, the ocean was family and ancestor. These stories told of voyaging and discovery, but also of reverence. The sea wasn't something to conquer, but something to consult, to sing to. Within its depths lived spirits, some playful, others fierce, but none indifferent. Among indigenous Australian peoples, there are stories of the rainbow serpent, not always oceanic, but deeply tied to water, flow, and creation. Its movement shaped the land itself. In some versions, the waters it inhabits lie far below, subterranean, sacred. In Japan, tales spoke of Yumibazu ghostly sea monks that would appear on calm waters, capsize ships without warning, and vanish into the fog. These stories weren't meant to explain particular sightings. They were reminders. The ocean listens. The deep especially remembers. In all these myths, the deep sea is more than a setting. It's a force. And it's almost always layered with meaning, the unconscious, the past, the divine, the dangerous, the origin of all things. It wasn't understood, but it was deeply felt. Even as human societies grew more curious in scientific ways, the old stories didn't vanish. They transformed. In the Middle Ages, maps sometimes marked the edges of the known seas with the words "Here be dragons." Cartographers filled blank spaces with drawings of tentacled beasts or great whales that could swallow ships whole. These weren't just decorative touches. They were placeholders for uncertainty. Where knowledge ended, imagination stepped in. Some believed the ocean simply dropped away into nothing. Others imagined hidden continents, Atlantis being the most famous, where advanced civilizations had slipped beneath the waves, punished or proud. By the 19th century, as the age of sail gave way to the age of steam, the sea's mysteries became more tantalizing than ever. Jules Verne wrote 20,000 Leagues Under the Seas in 1870. A work of fiction, yes, but one that reflected a very real fascination. What lies beneath? Verne's submarine, the Nautilus, was powered by technology that seemed futuristic for the time. But what made the story magnetic was the world it traveled through: glowing jellyfish, sunken cities, deep trenches, and crushing darkness. The sea wasn't just a backdrop. It was a character, indifferent, enigmatic, beautiful. While science began to take its first careful steps toward genuine exploration, the metaphors never stopped. The deep ocean became a mirror for the human mind, especially the unconscious. Freud, in the early 20th century, compared the psyche to an iceberg. What's visible is small, but what's hidden below is vast. Later psychologists used the same imagery. The sea became a symbol for the inner self, hidden, murky, slow-moving. Poets took it further. T.S. Eliot, Sylvia Plath, Pablo Neruda, they all wrote of the sea as both metaphor and mystery, something eternal, something within us. Music, too, has always known the sea. Sea shanties gave rhythm to hard labor, but they also carried warnings. Folk songs told of lovers lost to the waves. Ballads described sailors driven mad by endless horizons. Even lullabies, quiet songs meant for sleep, often borrowed ocean imagery. Waves, depth, the sense of being rocked by something older than memory. Here's the fascinating part. As our science improved, and as our instruments became more precise, our metaphors didn't disappear. They simply shifted. Today, when we talk about depth, we still mean more than physical distance. We speak of deep truths, deep thoughts, deep feelings. The ocean has imprinted itself on our language. The word unfathomable, now used to describe anything complex or surreal, comes directly from measuring rope length at sea. Plumbing the depths no longer means lowering a lead weight to the seafloor. It means searching the soul. And when we say something is oceanic, we don't just mean vast, we mean it overwhelms us with beauty, with meaning. That's the deep sea's legacy in human history, not just as a physical place, but as a canvas for wonder. And this matters, because how we feel about a place shapes how we treat it. We never approached the ocean the way we did the land. We revered it, we feared it, we sang to it. And even now, with all our tools, training, and technology, that reverence lingers. It's why the deep sea remains one of the last places on Earth where mystery is allowed to live. Think of this. When we send a machine to Mars, we call it a rover. It explores, it scouts, it brings back information. But when we send a probe to the bottom of the ocean, we often call it a descent. Same goal, different feeling. Down there, we descend as though into ourselves. Our ancestors may not have had deep-sea cameras or pressure gauges, but they had something else, a kind of spiritual sonar. They sensed what modern science has since confirmed. The ocean's depths are not empty, only unreached. And when we do reach, we bring more than equipment. We bring memory. We bring longing. Even now, in an age that claims certainty, we dream of Atlantis. We build entire worlds in video games set beneath the waves. We write films about sea creatures rising. We fill novels with submarines searching for ruins. We create aquariums, glass temples, where visitors stand before deep blue windows, gazing not just at fish, but at the feeling the deep stirs in them. And isn't it remarkable that after centuries of science, we still find ourselves where our ancestors once stood, at the edge of the sea, wondering, still whispering stories into the dark, still listening for answers in the hush between waves? It's tempting to say the deep sea remains unexplored simply because it's hard to reach, because of technology or funding or logistics. But maybe, just maybe, part of the truth is that we don't want to map it completely. Perhaps we need places that remain mythic, not because we fear them, but because we love them in a way that logic alone can't contain. After all, what is the deep ocean if not the original story, the first frontier, the last sacred space that refuses to be tamed? We've looked to the sky and found mathematics. We've looked to the atom and found uncertainty. But when we look into the ocean, we find something else entirely: ourselves. Our past, our fears, our dreams. And maybe that's something we're not ready to let go of just yet. So let's move from myth to method, from imagination to investigation. Because while the deep may inspire stories in the soul, it also presents real challenges to the body, to our machines, and to the mind. First, we have to be clear on what we mean by deep sea. The ocean isn't one uniform space. It's layered like a slow descent into night. With each level, the world grows stranger, darker, and more distant from what we know. At the very top lies the epipelagic zone, the sunlit layer. Here, light still filters through. Photosynthesis fuels vibrant ecosystems. This is where we swim, fish, sail, and dream. Below that, from about 200 to 1,000 meters, is the mesopelagic zone, the twilight zone. Sunlight fades. Temperatures drop. Many creatures here have large, sensitive eyes. Some carry their own light, gentle pulses of blue or green, drifting like fireflies in a distant storm. Beyond that is the bathopelagic, or midnight zone, from 1,000 to 4,000 meters. No sunlight reaches this depth. The cold hovers near freezing. Pressure climbs to more than 5,500 pounds per square inch, the weight of an elephant on every square inch of your body. Life here moves slowly. Creatures drift in darkness, adapted not for speed but for survival. Still deeper lies the abyssopelagic zone, from 4,000 to 6,000 meters. Temperatures stay just above freezing. Food is scarce. Many animals survive on marine snow, a constant fall of dead plankton, fish scales, and other organic fragments drifting down from above. And then comes the hadal zone, the trenches. These are the ocean's deepest reaches, found in steep, narrow valleys carved by tectonic forces. They plunge beyond 11,000 meters, deeper than Mount Everest is tall. We've explored less than 1% of them. At these depths, the ocean feels mythic again. Not because it's magical, but because getting there is so difficult that every glimpse feels like a miracle. So why haven't we explored more? The first and most obvious barrier is pressure. At the surface, we live under one atmosphere of pressure, the weight of the air above us. But underwater, pressure increases by 1 atmosphere for every 10 meters descended. By 1,000 meters, you're facing 100 times the pressure of the surface. That's not just uncomfortable, it's lethal. Human bodies aren't built for such conditions. Lungs would collapse, tissues would compress, senses would fail. We build machines to go there instead. But even those aren't immune. Pressure can crush steel, deform glass, and short-circuit electronics. Designing vehicles that can survive, let alone operate, in such an environment is an extraordinary engineering challenge. Take the DSV Alvin, one of the world's most famous submersibles. In service since the 1960s and operated by the Woods Hole Oceanographic Institution, Alvin can dive to about 4,500 meters. It has taken scientists to hydrothermal vents, to shipwrecks like the Titanic, and to countless new species. Its titanium sphere, the passenger cabin, is just big enough for 3 people. The walls are nearly 7 inches thick. Each dive takes hours to descend and ascend, for only a few precious hours of observation at depth. Only a handful of other vessels can go deeper. In 1960, the Trieste carried Jack Pickard and Don Walsh to the bottom of the Mariana Trench, nearly 11,000 meters. The trip took almost 5 hours down, 20 minutes at the seafloor, and 3 hours back up. In 2012, the Deep-Sea Challenger, piloted solo by filmmaker James Cameron, made the same journey, using modern instruments and cameras. Today, the vessel limiting factor is the most advanced in this field, capable of repeated dives to the ocean's deepest points. It's small, expensive, and remarkable, but it's also the exception, not the rule. Most oceanographic research doesn't involve sending people down at all. Instead, scientists use ROVs, remotely operated vehicles, and AUVs, autonomous underwater vehicles. These are controlled from ships or pre-programmed to roam and return. Even then, there are limits. Every camera and sensor must withstand immense pressure. Communication underwater is slow and unreliable. Radio waves don't travel well, so we rely on sound or physical tethers. Batteries run down. Strong currents can push machines off course. The ocean rarely allows neat, predictable paths. It's like trying to explore a dark, twisting cave with a flickering flashlight, while wearing thick gloves and operating by remote. Pressure isn't the only obstacle. There's also temperature. Most of the deep hovers around 24 degrees C, 35-39 degrees F. Electronics need insulation. Materials can become brittle. Oil thickens. Batteries drain faster. Even keeping a robotic arm moving smoothly can become a complex puzzle. And then, of course, there's darkness. Sunlight fades entirely by about 1,000 meters. Below that, there's no day or night, only perpetual shadow. Cameras need artificial lights, but those lights can scare away many animals. If you want to see creatures behaving naturally, you need infrared imaging, red filters, or complete patience. And patience is expensive. A single deep-sea expedition, ship rental, equipment, crew, scientists, can cost millions. Space programs get massive, sustained funding. Ocean research often has to fight for much smaller grants, shared among many projects. The result? We know the surface of Mars in greater detail than the seafloor of our own planet. That's not poetic exaggeration. About 25% of the ocean floor has been mapped with modern sonar. The rest is just rough outlines, guessed from satellite measurements of sea surface height. Those outlines are useful, but they can't replace direct exploration. You can't study an ecosystem or collect samples from orbit. Visibility is another paradox. Light is needed to see, but light changes what you're looking at. Many deep-sea creatures evolved in total darkness. Some have no eyes at all. Others can detect the faintest glimmer of bioluminescence, but not the harsh glare of white lamps. Imagine trying to watch deer in a forest, but every time you look, you shine a spotlight in their eyes. You won't see them acting naturally. To get around this, researchers use red light, softer LEDs, or passive sound monitoring. Some deploy landers, small platforms that sit on the seafloor and quietly record whatever passes by. These tools are improving, but progress is slow, and the ocean is vast. Studying it requires both scale and subtlety. Then there's the final, often overlooked barrier: time. The ocean is always moving. Tides rise and fall. Currents shift. Nutrients drift for days before settling. Events happen slowly or suddenly and are easy to miss. To truly understand the deep, we can't just drop in for a few hours. We have to stay. But long-term monitoring is hard. Saltwater corrodes equipment. Batteries fail. Cables snap. Even marine life can interfere. So much of what we know comes from short visits, hours-long glimpses of one small place on one day. Between those moments, silence. Yet despite these barriers, the crushing pressure, the cold, the cost, the time, we keep going back. Why? Because every dive brings something unexpected. A new species, a behavior we've never seen, an entire ecosystem that changes what we thought was possible. One of the most surprising deep-sea discoveries came in 1977. Scientists diving in the submersible Alvin reached the Galapagos Rift, a region where tectonic plates pull apart. They expected barren, freezing seafloor. Instead, they found hydrothermal vents, towering chimneys spewing superheated water rich with minerals. Around them, life thrived in a way no one had imagined. Giant clams, blind shrimp, tube worms taller than a person, with bright red plumes. These animals didn't rely on sunlight at all. Instead, they lived off chemosynthesis, a process where bacteria turn chemicals from the vent water into energy. This was a revelation. Ecosystems could exist entirely without the sun, powered instead by Earth's own heat and chemistry. It changed how we thought about life, not just here but everywhere. If it could exist in such extreme darkness and pressure, maybe it could exist in similar conditions on other worlds. On Europa, for example, Jupiter's icy moon, or Enceladus around Saturn. The deep ocean, in other words, isn't just a mystery, it's a model for thinking about life in the universe. Other divees have found equally strange wonders. In 2012, scientists filmed a giant squid in its natural habitat for the first time, a creature long thought to be pure legend. It moved with eerie grace, its tentacles trailing like ribbons in the dark. We've discovered black smokers, vents hotter than boiling water, and cold seeps, where methane bubbles up, feeding mussel beds and fields of tube worms. We've seen brine pools, underwater lakes of super salty water that sit on the seafloor like mercury, complete with distinct shorelines. Some of the strangest finds have been in the Hadal trenches. At depths where the pressure is more than 1,000 times that at the surface, life still persists: ghostly snailfish, translucent and delicate, drifting where no sunlight has ever reached. Each of these discoveries reshapes our understanding of biology, geology, and even climate. The deep sea is not isolated. It plays a role in regulating the planet's temperature, in storing carbon, in cycling nutrients. Currents that start in the deep move heat around the globe. Sediments lock away carbon for thousands of years. The deep is part of Earth's lungs and bloodstream. And yet, for all this importance, it remains mostly unseen. It's easy to forget how recent our exploration really is. The first photographic images of the deep seafloor were taken in the 1940s. The first crewed dives to truly deep places happened only in the second half of the 20th century. In human history, that's a blink. Before that, the deep was only known through nets, clumsy, destructive, and often misleading. Now we can observe without destroying, record without removing. But those abilities are still rare and costly. And while science advances, industry also has an eye on the deep. There's growing interest in deep-sea mining, extracting metals like cobalt, nickel, and rare earth elements from the seafloor. These materials are critical for batteries, electronics, and renewable energy technologies. The richest deposits are often found around hydrothermal vents or in fields of manganese nodules, potato-sized lumps scattered across abyssal plains. But here's the concern. These are not lifeless zones. They are ecosystems that may take centuries to form. Disrupting them could have effects we can't predict. Unlike forests or reefs, which we can monitor over decades, the deep is slow to reveal damage and slow to recover. Many scientists argue for caution, calling for research before extraction. Others push for international agreements to protect certain areas entirely. It's a reminder that mystery is not just romantic, it's protective. When we don't fully understand a place, we risk harming it without realizing the cost. The deep sea is not empty. It is not separate. It's part of our planet's life support system. And yet, I think part of the reason it still captures our imagination is precisely because it is not entirely known. Every time we send a vessel down, there's a chance, however small, of finding something no one has ever seen before. And that's rare in the modern world. Think of the first time you saw an image of the giant squid, alive, or the first video of glowing siphonophores drifting like chandeliers through black water. Those moments remind us that wonder isn't just for children. Exploration, in its purest form, isn't about conquering or claiming. It's about noticing and then sharing what you've noticed. And maybe that's why we return to the deep, even knowing its dangers, even facing its costs. Because the moment the lights go on and the cameras capture something alien and perfect, the distance between us and that hidden world collapses. For a few minutes, the unknown becomes known, and yet somehow the mystery deepens. The ocean has a way of giving answers that lead to more questions. It shows us that life can exist without sunlight, that ecosystems can thrive where they shouldn't, that beauty can flourish in the cold and the dark. It hints, gently but firmly, that we do not yet know the full story of our own planet. And maybe that's the point. Perhaps the deep sea remains unexplored not just because it is hard to reach, but because it is teaching us the value of patience. Not everything needs to be mapped in a single lifetime. Not every place needs a permanent footprint. Some can remain for a while longer as they have for millions of years, silent, slow, and waiting. So next time you hear the hush of the waves, think of the world below. The zones of twilight, midnight, and trench. The vents, the brine pools, the drifting snow of the abyss. Think of the life that glows in its own light. The creatures that never see the sun. The pressure that could crush steel but not the persistence of life. And know that somewhere far below the surface, there is a place untouched. A place that holds stories we haven't yet learned to tell. And that, in a world so mapped and measured, might be the greatest treasure left. When we talk about exploration, we often picture people as astronauts floating in zero gravity, climbers at the summit of Everest, divers surrounded by coral light. But in the deep sea, most exploration is done without human eyes on location. This is where technology becomes our stand-in. Cameras, sensors, robotic arms, all acting as our extensions, reaching into the dark where we cannot go. The earliest deep-sea research relied on dredges and trawls. Heavy nets dragged along the seafloor, hauling up whatever they caught. It worked, in a crude way, but destroyed habitats and gave only broken glimpses of life. Then came cameras, first still images, then film, now high-definition video. But cameras need light, and as we've learned, light changes behavior. So researchers developed low-light sensors and gentle illumination. The result? Footage of animals undisturbed, moving as they have for millennia, unaware of our presence. One of the most striking developments in recent decades has been the autonomous underwater vehicle, or AUV. These machines are pre-programmed with routes and tasks. They roam for hours or days, mapping, measuring, filming. Some AUVs skim just above the seafloor, using sonar to produce maps so detailed they can reveal rocks the size of a small table. Others travel mid-water, sampling plankton, recording temperature shifts, listening for whale calls. And then there are ROVs, remotely operated vehicles. Tethered to a ship by a long cable, they send live video to the surface. Scientists can watch in real time, guiding the ROV with joysticks, collecting samples with robotic claws, or placing instruments on the seafloor. An ROV dive is slow, careful work. The pilot has to adjust constantly for currents, avoid stirring up sediment, and keep delicate arms steady while operating in pitch darkness. It's a strange blend of patience and precision. In recent years, landers have also become important. These are simple platforms dropped to the seafloor with cameras and sensors. They stay for days or weeks, silently recording whatever drifts by. This kind of patient observation has revealed behaviors we never knew existed, like fish visiting bait stations in orderly turns, or deep-sea crabs gathering in the thousands for reasons still unknown. The data from these tools builds our understanding piece by piece. And that understanding is not just academic, it has real-world consequences. For example, deep-sea currents influence climate patterns. Studying them helps us predict changes that affect agriculture, storm intensity, and global temperatures. Deep-sea sediments store carbon for centuries. If disturbed, that carbon could re-enter the atmosphere, contributing to warming. Even the chemistry of hydrothermal vents has applications. Some bacteria found there produce enzymes used in medicine and industry. The deep is a resource in ways we're still discovering, but it's also a reminder that resources are not just things to take, they're systems to protect. This is where ethics enters the conversation. Exploration is not neutral. Every action we take in the deep has consequences, even if we can't see them immediately. A submersible passing overhead can disturb sediment that took centuries to settle. The sound of a propeller can alter animal behavior. Even the heat from a lamp can affect tiny creatures. And when extraction is involved, whether it's fishing, mining, or drilling, the scale of impact grows. Deep-sea trawling, for example, can flatten coral reefs that took thousands of years to grow. Once gone, they may never return. Mining can strip mine entire fields of manganese nodules, destroying habitats in the process. The plumes of sediment stirred up can drift for miles, smothering life elsewhere. The challenge is this: we know too little to fully understand the damage. That's why many scientists argue for a precautionary approach, to slow down, to study before acting, and to protect large areas outright. Some steps have been taken. Marine protected areas now cover parts of the ocean, including deep regions. These are like national parks beneath the waves, zones where extraction is banned or limited. International bodies like the International Seabed Authority regulate activity in areas beyond national borders, but enforcement is difficult. The deep is vast and surveillance is limited. Still, the conversation is shifting. More people are beginning to see the deep not as a void waiting to be used, but as a living system with value beyond economics. And this shift matters because, in the end, our treatment of the deep says something about us. Do we see it as a challenge to conquer, or a realm to understand and protect? This is where storytelling becomes more than decoration. Stories, whether they're myths, documentaries, or quiet bedtime narrations, shape perception. If people imagine the deep only as a place of monsters, they might not care what happens to it. If they imagine it as empty, they might not notice when it's gone. But if they imagine it as alive, intricate, and connected to their own lives, they may feel differently. That's why even now, with satellites, sensors, and robotics, we still need language, the poetry of depth, the metaphor of light in darkness, the reminder that mystery has value. Science can show us what is there. Stories can remind us why it matters. And maybe this is why the deep remains partly unexplored. Not because we lack the tools, but because we are still learning how to look. Not just with cameras and sonar, but with perspective. The ocean, in all its layers, demands both skill and humility. It will not give up its secrets to haste. And perhaps that's the lesson. Exploration is not just movement into space, it's movement in understanding. It asks us to be patient, to return again and again, to notice more each time. And when we do, we may find that the deep is not just a place, but a way of seeing, one that changes how we understand the surface and ourselves. So, as our technology improves and as we push deeper, we should remember the quiet truth. Discovery is not an ending. It's a beginning. Each new glimpse into the deep is like opening a window in a dark house. The light spills in, and suddenly we realize there are more rooms than we thought. And the deep, with its slow currents and glowing life, will wait for us to explore them. When we imagine the deep sea, we often picture it as empty, cold, and lifeless. But the truth is far stranger and far more alive than most people realize. Life at depth looks nothing like life at the surface. Here, creatures adapt not to warmth and light, but to crushing pressure and endless darkness. Their shapes, colors, and behaviors are often beyond what we would have thought possible. Some are transparent, their bodies so clear you can see their organs floating inside. Others glow with bioluminescence, blues and greens, sometimes reds, spirals of light pulsing along tentacles or flickering in a slow rhythm. The lanternfish, for example, is small, but among the most numerous vertebrates on Earth. It spends its days in the dark mesopelagic zone, then rises toward the surface at night to feed, part of the largest daily migration of life on the planet. There's the gulper eel, with a mouth so large it can swallow prey nearly its own size. The barrel-eye fish, with a transparent head, lets us see its eyes pointing upward through a dome of clear tissue. Some deep-sea squid release clouds of glowing fluid to confuse predators. Certain jellyfish can turn their entire bodies into spiraling neon displays, creating light in a place where the sun has never reached. And then there are the giants, colossal squid, larger than a bus, their tentacles armed with swiveling hooks. Sperm whales dive deep to hunt them, carrying the scars of those battles back to the surface. The deep also holds creatures older than we can imagine. Some corals grow at just a few millimeters per year, forming reefs that may be thousands of years old. There are sponges that have lived for centuries, filtering water in the same quiet rhythm for generations. Every discovery adds to the sense that the deep is not just a place, it's a time capsule. It holds species and lineages that connect us to a more ancient Earth, before forests, before grasslands, before most of what we think of as life on land even existed. But these creatures are also fragile. They have adapted to a very specific environment, one with constant cold, constant pressure, and little disturbance. When we fish too deep, mine too roughly, or pollute too heavily, they may not survive the changes. And because we know so little, the loss can happen before we even realize what's gone. This is part of why deep-sea exploration is more than just curiosity. It's a way of taking inventory, of understanding what is there before we make choices that cannot be undone. Exploring the deep is also exploring the limits of our own creativity. Each new adaptation we see down there, each unexpected shape, color, or survival strategy, reminds us that life finds a way, even under the most extreme conditions. Some scientists are studying deep-sea microbes for medical purposes. Enzymes from bacteria found in hydrothermal vents, for example, can withstand high temperatures and pressures, making them useful in pharmaceuticals, industrial processes, and genetic research. Other researchers look to the deep for engineering inspiration. The structure of certain fish scales, the design of squid beaks, even the light patterns of bioluminescent plankton can lead to new materials, new coatings, new technologies. But in all this potential, there's a thread of caution. The deep is not a laboratory we can control. It's a living system, and one that we enter as guests, guests who don't yet understand the full house. This is where the role of the sleepy narrator and storytellers like them becomes essential. Science gathers the data, but it's the story that helps people care about it. Numbers may fade, but an image, a glowing jelly drifting in the dark, a whale diving into silence, stays in the mind. We remember what we feel, and the deep, when described well, makes us feel something rare. It makes us feel small, but not in a way that's discouraging. Small in a way that connects us to something bigger. Because the deep is not separate from our lives. It's part of the same earth, part of the same cycles that shape the air we breathe and the weather we feel. Waves we see on the shore are connected to currents that move through the abyss. Storms we track in the sky can begin as temperature differences in the sea. Even the sand on a beach may have once been part of a deep-sea shell, crushed and carried upward over centuries. In this way, exploring the deep is a reminder that nothing on Earth is truly isolated. Everything moves, connects, and transforms. And perhaps that's the quiet truth at the heart of it. We explore not to escape our world, but to understand it more fully. We push into the dark because it's part of the same home. And even if we never map every trench, never see every creature, the act of looking changes us. It teaches patience, humility, and the value of leaving some doors unopened until we are ready to enter with care. In the end, the deep may be less about what we take from it, and more about what it leaves in us. A sense of wonder, a respect for resilience, and a reminder that our world is wider, older, and more intricate than we can measure. And maybe that's the best reason to keep exploring. Not to finish the map, but to keep the conversation between the surface and the depths alive. Because as long as we keep asking what's down there, we're also asking something about ourselves. And the ocean, vast and unhurried, will be here to answer in its own time. In many ways, our journey into the deep ocean is still in its earliest stages. We've built remarkable machines, sent them farther than we ever thought possible, and brought back images that challenge our understanding of life. Yet compared to the size of the ocean, our efforts are still tiny. Imagine walking into a vast library, millions of books, stretching endlessly in every direction, and realizing you've only read a few pages from a handful of volumes. That's where we are with the deep sea. We've sampled small areas here and there, but most of the collection remains closed. And like a library, the deep contains more than facts. It holds stories. Each creature, each current, each seafloor formation is a chapter in Earth's history. Some of these stories are geological. The shape of the ocean floor tells of continents shifting, mountains rising, trenches opening. The mid-ocean ridge, for example, is the longest mountain range on Earth, more than 65,000 kilometers long, much of it hidden under thousands of meters of water. Along this ridge, new seafloor is constantly forming as magma rises and cools. Other stories are biological. The deep contains lineages that stretch back hundreds of millions of years, surviving mass extinctions and climate shifts that reshaped life on the surface. In some ways, it is a living archive, not frozen in time, but evolving slowly, steadily, almost imperceptibly. And then there are chemical stories. The way elements move through water, the way gases are stored, the way minerals dissolve and reform. These processes may be invisible to the naked eye, but they shape everything from weather patterns to the composition of the atmosphere. Every expedition into the deep uncovers fragments of these stories. A sample of sediment here, a video of a strange fish there, each piece adding to a picture that is still incomplete. But filling in that picture is slow work. The logistics are challenging. Ships capable of deep-sea research are few, and the time available for expeditions is limited. Weather can delay launches. Equipment can fail. Even in perfect conditions, travel time to and from the deepest zones leaves only narrow windows for observation. And the ocean itself is unpredictable. Currents shift unexpectedly. Visibility can change in moments. A sudden tangle in a tether can end a dive early. This unpredictability means that much of deep-sea research requires flexibility. Scientists plan meticulously, but they also adapt quickly, changing objectives when conditions demand it. Sometimes, a failed dive leads to an unplanned discovery, a detour that reveals something even more remarkable than the original target. That adaptability is one of the quiet strengths of ocean exploration. It mirrors the very nature of the sea, fluid, dynamic, and full of surprises. One such surprise came during an expedition to study hydrothermal vents. An ROV was descending toward a known vent field when it encountered something unexpected: a massive aggregation of octopuses clustered on a rocky slope. They were guarding eggs, hundreds of them, in an area warmed by faint geothermal heat. No one had ever seen this behavior before. The find raised new questions about deep-sea reproduction, temperature preferences, and the role of geothermal activity in animal life. Moments like this remind us that exploration is not just about confirming what we think we know, it's about being ready for the unknown. In that way, the deep teaches a lesson that applies far beyond science. Sometimes the most valuable discoveries are the ones we didn't set out to find. And while technology lets us reach deeper than ever, there is still a uniquely human element to exploration. The excitement of seeing something new, the patience required to wait for hours in darkness, the quiet awe of realizing you're watching a scene unfold that no one has ever witnessed before. These are experiences that connect the scientists on board to every explorer in history. It's also what connects them to us, through the voices and images they bring back. When the sleepy narrator describes a deep-sea jellyfish or the shimmering walls of a vent chimney, they are translating not just data, but wonder. That translation matters. Without it, the deep risks becoming invisible again, a place too far away for most people to think about, much less care about. And caring matters because the future of the deep is not guaranteed. Climate change is already affecting ocean currents, oxygen levels, and temperatures. Even subtle shifts can ripple through deep-sea ecosystems. Species adapted to narrow temperature ranges may struggle to survive. Changes in surface productivity can reduce the marine snow that feeds life below. Acidification, caused by excess carbon dioxide, can dissolve the shells and skeletons of deep-sea corals. These impacts are slow compared to surface changes, but they are no less real. And once they take hold, recovery may take centuries if it happens at all. This is why scientists often speak of the deep with both excitement and urgency. It is a place of marvels, but also a place under threat. Protecting it means acting before the damage is obvious. That requires foresight, and foresight requires awareness. Which brings us back to storytelling. The ocean may not speak our language, but it communicates through the patterns of its currents, the structures of its reefs, the migrations of its creatures. Translating those patterns into something we can understand and care about is part of the work. It's why exploration is not only for scientists. Artists, writers, filmmakers, and narrators all have a role to play in making the deep real to those who will never see it firsthand. Because in the end, what we protect is often what we've learned to imagine. If we can picture the deep as more than empty space, if we can picture its forests of coral, its drifting lanternfish, its ancient ridges and trenches, then we are more likely to value it. And valuing it may be the difference between a future where it thrives and one where it is quietly diminished. So we keep exploring, keep telling, keep imagining. Not because we will ever finish the map, but because the act of looking changes both the viewer and the viewed. The deep is still there, waiting not impatiently, but in the same slow rhythm it has kept for millions of years. And if we are wise, we will meet it with the same patience, the same openness to surprise, and the same respect for its mysteries. In every era, human exploration has followed a pattern. First comes the whispers of what might exist beyond the known. Then comes the first brave attempt, often clumsy and uncertain. And finally, the steady refinement of tools and methods until the unknown becomes part of the map. With the deep ocean, we are still somewhere between that second and third stage. We have moved past the age of rumor. No one doubts there is life below, or that the seafloor is as varied as any landscape on land. But we are far from the point where we can explore it with ease or completeness. For one thing, the sheer scale is daunting. More than 70% of our planet's surface is ocean, and the average depth is nearly 4 kilometers. That means most of Earth's habitable space, by volume, is deep ocean. Mapping it all would take centuries, even with the best technology we have today. And in that time, the ocean itself will change, reshaped by shifting currents, moving sediments, and evolving life. Then there is the complexity of its environments. The deep sea is not one uniform zone. It is a patchwork of habitats, each with its own temperature, chemistry, and pressure. Hydrothermal vents differ from cold seeps. Seamount slopes differ from abyssal plains. Trenches differ from mid-ocean ridges. Each requires different tools to study, and each reveals its secrets at its own pace. Even so, our progress has been remarkable. In just a few decades, we've gone from grainy black and white photos to high-definition video streamed live from the bottom of the ocean. We've tracked the daily migrations of fish, mapped the undersea equivalent of mountain ranges, and identified entire ecosystems powered not by sunlight, but by chemical energy. Some of the most exciting work today involves combining different kinds of data. Sonar maps show the shape of the seafloor. Temperature sensors reveal currents. DNA sampling from water can detect the presence of species without ever seeing them. Put together, these methods give us a more complete picture than any single approach could. But no matter how advanced the technology, there is still something irreplaceable about seeing. When the Sleepy Narrator describes a deep-sea scene, there is a texture to it. The slow sweep of a camera light over a vent chimney, the way particles drift through the beam like snow in still air, the sudden appearance of a shadowy form in the distance. Those moments remind us that exploration is more than information. It's also experience, the feeling of being present in a place few have ever been. And sometimes, those feelings carry unexpected weight. On one dive, researchers came across a single plastic bag lying on the seafloor, more than 1,000 meters down. It looked out of place in the vast, quiet landscape, a reminder that our reach extends farther than we often realize. Microplastics have been found in deep-sea sediments, even in remote trenches. These particles, too small to see, can be ingested by marine life, working their way up the food chain. This is one of the great paradoxes of the deep. It is remote, yet connected. Our actions at the surface, what we burn, what we discard, what we spill, can find their way into its depths. It means that protecting the deep is not only about regulating deep-sea industries. It's also about changing how we live on land. In that sense, the ocean is both a mystery to be solved and a mirror held up to ourselves. It shows us the scale of our ambition, but also the scale of our impact. And perhaps this is why deep-sea exploration is more than just science. It is a practice of reflection, not just on what is out there, but on how we choose to engage with it. We could approach it with urgency, taking what we can before it's gone. Or we could approach it with patience, letting discovery unfold at a pace that matches the slow heartbeat of the deep itself. Patience has its rewards. Life in the deep often moves slowly, but it can also surprise us with sudden displays, a squid darting into view, a jellyfish expanding and contracting like a luminous heartbeat, a fish flashing light in patterns we don't yet understand. These moments are fleeting, and they cannot be rushed. They happen when they happen, which is perhaps the hardest lesson for a species used to speed, used to satellites that map continents in days, to messages that travel around the globe in seconds. The deep reminds us that some things unfold over decades, centuries, or more, that some stories are not meant to be finished quickly, and that maybe not finishing them is part of the point. Because the deep is not just a resource to be cataloged or exploited. It is also a source of humility, a place that tells us, gently but firmly, that we do not know everything, and that we may never know everything. That reminder is not a limitation. It's an invitation to keep looking, to keep listening, to keep imagining what might be waiting beyond the range of our lights, and to remember that the unknown is not something to fear, but something to respect. We are, after all, creatures of the surface, but the deep is part of our planet, part of our history, and part of our future. It will always be there, waiting, patient, unhurried, and full of stories we have yet to hear. There is a saying among oceanographers: we know more about the surface of the moon than we do about the bottom of our own ocean. It's not an exaggeration. Satellites have mapped the moon in exquisite detail, but when it comes to the deep sea, most of it remains unknown. Part of the reason is technological. Radar and laser scanning work well in space, where there's no water to block the signal. But in the ocean, light and radio waves fade quickly. Even powerful sonar has limits, and mapping large areas takes time. Another reason is cost. Deep-sea expeditions require specialized ships, advanced submersibles, and teams of trained experts. These are expensive to build, operate, and maintain. A single voyage can cost millions of dollars, and funding for such work is always limited. And yet, despite these challenges, there is a growing momentum in deep-sea exploration. New nations, universities, and private organizations are joining the effort. Technology is becoming smaller, cheaper, and more efficient. Some of the most promising developments are in autonomous systems. Imagine fleets of small, battery-powered vehicles moving silently through the ocean, each equipped with cameras, sonar, and environmental sensors. They could map large areas in weeks rather than decades. Paired with machine learning, this technology could help identify patterns we might otherwise miss. The way certain species cluster, the subtle changes in temperature that signal a vent, the faint echoes of geological features hidden under sediment. But even with faster tools, there is an important truth. Mapping is not the same as knowing. A map can tell you where a trench is, but not what lives in it. It can show the shape of a ridge, but not the chemistry of the water that flows over it. To know those things, we have to visit. And visiting the deep is still an event, rare, carefully planned, and often unpredictable. Every dive carries risk. Equipment can fail under the crushing pressure. Currents can push a vehicle off course. Sediment can cloud cameras. Even small problems can end a mission early. But when a dive succeeds, the rewards are unforgettable. In one mission, scientists found a coral reef 200 meters tall, hidden in a region thought to be barren. In another, an ROV recorded a siphonophore, a colony of individual organisms living together, more than 40 meters long, coiling through the water like a living ribbon. These finds are not just beautiful. They expand our understanding of what is possible. They also remind us how much remains to be seen. If such wonders can be found in places we thought were empty, how many more might be waiting? And here is where the sleepy narrator and voices like theirs play a quiet but powerful role. Exploration without communication is only half the work. The other half is sharing not just the data, but the experience. Because while most people will never dive to the ocean floor, they can still be part of the story. They can see the footage, hear the descriptions, feel the wonder. That connection matters especially now, when human impact reaches even the most remote depths. Climate change, pollution, overfishing, and potential deep-sea mining are pressing concerns. If the public sees the deep only as an empty void, there will be little resistance to its exploitation. But if the deep is seen as a living world, intricate, fragile, and connected to the surface, the case for its protection becomes stronger. This is why scientists, conservationists, and storytellers often work together. One gathers the knowledge, one builds the legal and political framework, and one inspires the sense of value that makes protection possible. And protecting the deep is not only about preserving beauty. It is about safeguarding the systems that keep our planet stable. Deep currents distribute heat around the globe. Deep sediments lock away carbon. Deep ecosystems recycle nutrients. Disrupt these processes, and the effects will be felt far beyond the ocean. This is not abstract. The food we eat, the weather we experience, and the air we breathe are all influenced by the state of the deep ocean. Which means that when we talk about the future of the deep, we are also talking about the future of ourselves. The decisions we make in the next few decades about mining, fishing, climate policy, and pollution will determine whether the deep remains a thriving part of Earth's system or becomes a damaged, diminished shadow of itself. There is still time to choose wisely, but wisdom requires awareness, and awareness requires attention. And attention, in our fast-moving world, often begins with a moment of stillness, with the pause that comes when someone shares an image or a story so compelling that we stop what we're doing and listen. The deep has that power. A glowing jellyfish, a strange fish with a transparent head, a slow drift over a seafloor vent. These images can cut through noise and distraction, anchoring us to something bigger than ourselves. We may never know the deep completely, but knowing it partially and knowing it well may be enough to inspire the care it needs. And in the end, that care may be the most important discovery we ever make down there. Exploration has always been a balance between curiosity and caution. We are drawn to the unknown, yet aware that entering it changes both us and the place we explore. The deep ocean makes that balance especially clear. It is vast, mysterious, and challenging, but also delicate in ways we are only beginning to understand. We have learned much in the last century. We have sent people to the deepest trenches, mapped underwater mountains taller than Everest, and discovered ecosystems that thrive without sunlight. We have watched creatures glow in perfect darkness, drift in slow patterns that seem like choreography, and survive pressures that would crush steel. And yet, what we know is still only the smallest fraction of what there is to learn. Every dive, every image, every sample adds to a growing mosaic, a picture of a living world that is far more complex and interconnected than we imagined. Some discoveries hint at practical uses. Microbes that can survive extreme heat and pressure may lead to new medicines or industrial processes. The study of deep-sea currents helps improve climate models, which in turn inform agriculture, disaster planning, and energy use. Other discoveries speak to the human spirit. They remind us that beauty exists in places we may never visit. They show us that life adapts in ways we cannot predict, and some discoveries are warnings. They reveal the reach of our pollution, the fragility of certain species, and the potential consequences of careless extraction. The deep is not separate from the surface. It is connected through currents, chemistry, and biology. What happens above will eventually be felt below, and what happens below can shape the surface in return. That connection is both a responsibility and an opportunity. It means that by protecting the deep, we are also protecting ourselves. By studying it, we can better understand the systems that make life possible on Earth. By telling its stories, we can inspire care for something most people will never see with their own eyes. This is why voices like the Sleepy Narrator matter. Data can be stored in archives, but stories live in people's minds. A map can show where something is, but a story can make someone care whether it stays there. And care is what will determine the future of the deep. Because in the end, exploration is not just about reaching new places. It is about deciding what those places will be when future generations arrive. We can choose a future where the deep is a living, thriving realm, full of creatures and processes we barely understand. Or we can choose a future where much of it is damaged before we even knew it was there. The difference between those futures is not a matter of technology, it is a matter of will, and will often begins with wonder. So we keep sending ships, submersibles, and robots. We keep mapping, sampling, filming, and listening. We keep telling the stories of what we find, so that others can share in that wonder. The deep will not give up its secrets quickly. It has been here for billions of years and will remain long after we are gone. But for the short time we share this planet, we have the chance to know it and to care for it in a way no generation before us has. That is the real promise of exploration. Not just to see what is there, but to leave it better than we found it. And perhaps, one day, we will look back on this moment in history and see it as the time we began to truly meet the deep. Not as an obstacle, not as a resource, but as a partner in the story of life on Earth. Until then, the ocean waits. Its currents move in ancient rhythms, its creatures live in slow cycles, its mountains and plains stretch beyond the reach of light. It waits for us to come with open eyes, careful hands, and a willingness to listen. And when we do, we may find that the greatest discovery is not what we take from the deep, but what it leaves within us.